One of the final technical drawings required before commencing the construction of a building complex is the site plan. But what exactly is a site plan, and what does it encompass? Site plans are detailed maps that illustrate the outer boundaries of the building, its location in relation to the surrounding land and neighboring structures, the positioning of vegetation relative to the building, and the access roads leading to it. With site plans, we can accurately represent all these elements on our property. For this, we have two methods of locating, traditional and modern. In the traditional method of positioning, we designate one corner of the plot as a reference point. From this point, we draw a 3-meter line and a 4-meter line in two different directions. According to the Pythagorean theorem, if the line connecting the ends of these two lines measures 5 meters, then our lines will be perpendicular to each other. Using this principle, we can establish lines of the desired length. For instance, to create a line measuring 15 meters, we would repeat this process 5 times. If we need to determine another 15-meter line, we first repeat the process 4 times to generate a line of 16 meters. Then, by moving back 1 meter, we achieve a line measuring 15 meters. We apply this technique to various sections of our building until all outer walls are accurately positioned. Now, let's discuss the modern positioning method. For example, suppose we want to determine the area of our rectangular building, which measures 30 meters by 15 meters. In this scenario, the 30-meter side is situated 12 meters from the main street axis, while the 15-meter side is positioned 6 meters from the side street axis. Our first task will be to locate the axes of the main and side streets. Once identified, we will draw a line parallel to the main street at a distance of 12 meters from its axis. Next, we will draw another line parallel to the side street at a distance of 6 meters from its axis. The intersection of these two lines will mark one corner of our building. Using a theodolite and a laser tape measure, we will establish a point 30 meters away from the first point and parallel to the main street and another point 15 meters away from the first point and parallel to the side street. By identifying these points, we will have located 3 of the 4 corners of our building. To find the final corner, we will again utilize the theodolite and the laser tape measure. Once all corners have been identified, we will measure each section. If any measurement error exceeds 2 centimeters, we will repeat the entire process from the beginning. It is crucial that our drawing maintains an accuracy within 2 centimeters. After determining the corners of our building, we will establish 2 reference points for each corner. This way, if the initial point is compromised during construction, we can restore it to its original location using these reference points. To create these reference points, we will extend lines a certain distance from each corner. However, our site plans are not always simple rectangles. If our site plan has a more complex shape, we can simplify our work by enclosing the entire site within a larger rectangle. We will then draw all necessary elements based on this larger rectangle. For example, we might draw a vertical line measuring 3 meters at a distance of 5 meters from the northwest corner. Before commencing construction on the designated land, we must prepare the site by making necessary adjustments. This preparation process involves 2 primary tasks: excavation and embankment. Excavation refers to the process of removing soil to achieve the desired depth, while embankment involves filling an area with soil to reach the desired height. When performing embankment operations on a section of land, it is essential to ensure that the thickness of the soil layer does not exceed 30 centimeters. It is important to remember that this embanked layer cannot support any loads. Therefore, if we intend to place a load on this embanked layer, we must first compact it. We can achieve compaction using a road roller. We will continue this process until the thickness of the embanked layer is reduced to less than 15 centimeters. Now, if we want to create an embankment with a height of 90 centimeters, what steps should we take? To accomplish this, we will need to perform the embankment and soil compaction operations 6 times in succession to achieve the desired height of 90 centimeters. However, according to regulations, we cannot construct an embankment exceeding 15 centimeters in height without providing adequate support. To address this issue, we can create smaller layers during the embankment process. Once we reach the desired height, we can reinforce the sides with steel mesh and apply concrete over it. Alternatively, we can use a retaining wall to stabilize the embankment. Thank you for joining us. We hope you found this tutorial helpful. Don't forget to follow our channel for more informative videos.